Well, we've been solving cubic equations and quadratic equations, solving those pretty well. We've learned how to simplify radicals and estimate square roots and cube roots and that sort of thing. And we're now ready to do some operations. So the first thing we're going to learn is we're going to learn how to add and subtract square roots. Or in other words, we're going to say it this way: I can combine square roots. So go ahead and write the word combine here. And we're going to combine square roots kind of like we combine like terms and combine integers and different things like that. So the warm-up has us combining the terms in this expression right here. So I'm going to put a little swooping line underneath the 4x and the negative 5x. And I'm going to put a little boxed line underneath the negative 2y and the positive 10y. And then that negative 9, that constant there, we're just going to put on the end. And again, we normally put them in alphabetical order. So we're going to go 4x minus 5x. That's negative 1x, or just negative x. And then we've got the negative 2y and the positive 10y. Different signs, we're going to find the difference. The difference is 8 and the bigger one is positive, so that's going to be positive 8y. So we're done with all of those, and the only thing left is that constant negative 9, and we're going to put that on the end. So this would be the answer right here. And we've practiced stuff like that before. We learned that probably last year. We should be pretty good at that by now. But I do have a question for you. How can you tell if terms are like terms, so that we can combine those? And we're going to talk about that in just a second, so I want you to keep that in mind as we continue talking here. So adding and subtracting radicals, or in other words combining radicals, is very similar to combining terms for other expressions that we've worked with already this year and last year. We can only combine like terms. They have to be like terms. Now when we're dealing with variable expressions, we already know what it means for them to be like terms. If they're like terms, they have to have the same variable. So I'm going to write the word variable here. And I'm also going to put an S on the end of that, because if they have more than one variable, we have to check and make sure that they have all the same variables, and they've got to have the same exponent, or they've got to have the same exponents if there are more than one of them. Now when we're dealing with radical expressions, like terms have the same, we're going to say this: they have the same root, which means they have the same index. So we can't mix square roots and cube roots and fourth roots together. Okay, so they've got to all be square roots or all cube roots if they're going to be like terms. And they've got to have the same radicand. So this kind of rolls off your tongue. They've got to have the same root, and they've got to have the same radicand. All right, so they've got to be the same root, same square root, cube root, or whatever, and they've got to have the same number underneath. Remember, the radicand is the fancy word for what goes underneath. Now, in this particular section, in 8th grade, we're only going to be dealing with square roots. All right, so the root is automatically the same. All we need to do is make sure that each term is simplified, so we're going to write simplified here, and that each radicand is the same. So they're all going to be square roots. We're going to make sure that they're simplified. We're going to make sure that the radicands are all the same. And if the radicands are not the same, so if they are not the same, then we cannot combine them. And we will run into things where we can't really combine anything. We can only simplify each one of the terms. So I want you to take a look at example number 1. Now, I'm going to show you that you kind of already know how to do this problem. I'm going to change colors, and I'm going to write it like this. If I had an x plus an x, you would know what the answer is. This literally means 1x plus another x, so the answer would be 2x. Okay, no problem there. And I'm going to show you an example for this one. If I had 4y minus 9y, you would know what the answer is on that one also. So they're like terms. If I have 4y's minus 9y, I would have minus 5y. Now, this is already simplified. The radical 15, we happen to have 2 of them. This is 3 times a 5, so there are no pairs of factors to take out or anything like that. So I've got a radical 15 plus a radical 15. Or I'm going to say it this way. What if I had 1 radical 15 plus 1 radical 15? Well, what that would give me is that would give me 2 radical 15s, and we would be done right there. That's it. Again, if you wanted to double check and make sure that this was simplified, we've got a 2 on the outside, and I could write this down as, 3 times 5. but you'll notice that there are no pairs of factors, so 3 times 5 is just 15. This is the best way to write it. And definitely it is not this. Please don't go through here and think, okay, this is radical 15 plus radical 15, that's going to be radical 30. It is not radical 30. That's a completely different number. Okay, we're figuring out how many of these radical 15s we have. Okay, we can't suddenly change that to be something different underneath. It doesn't work that way. Okay, so let's take a look at the next one. If I have 4 radical 7s minus 9 radical 7s, well, these are definitely like terms. We have the same root and the same radicand. Okay, they're both square roots and they're both radical 7s. So this is going to be 4 of these minus 9 of these. This is going to be negative 5 of those. Okay, not negative 5 of something else, not radical 14 or something weird like that. Okay, so that's the answer on that one. And then let's take a look at this one. This one's kind of interesting. There are a couple different approaches we could use on this one. If I have a radical 18 plus another radical 18, probably the best thing to do with that is to say that that's going to be 2 radical 18. And then we want to make sure that this is simplified. Remember, to simplify these, we want to take out pairs of factors. So I'm going to do 2 times 9, which is 3 times 3. So this already has a 2 out front. It's got a 2 underneath, a 3 underneath, and another 3 underneath. So we've got a pair of factors right here. So we've got a pair of 3s. So we're going to take that 3 on the outside. Notice what's stuck underneath. The 2 is stuck underneath. So I've got 2 times 3 on the outside. That's going to be a 6. And I'm left with a radical 2. Okay, so that's the simplified answer there. Now you'll notice that on each one of these they kind of looked like they're like terms. A radical 15 here and a radical 15 here, a radical 7 here and a radical 7 here, and then a radical 18 and a radical 18. So it kind of looked like they were the same. The ones down here, they do not look like they're the same, but don't give up on them just yet. Now before I start with number D, I just want to point out something. There would be a flaw in the logic of adding these together and saying that that's going to be radical 13. Because if by that logic you add these to, radical 30. If by that logic you add these together and get radical 30, what would you do when you subtract? Would you have radical 0? That wouldn't make much sense. So there's a big flaw there. So please don't just add those together underneath the radical. It does not work that way. We're looking for the same root and the same radicand, and then we're just counting up how many there are, just like we're counting up how many x's we have here. So you'll notice that these are both square roots, but one has a radical 3 and the other one is a radical 27. Clearly not the same. So what we do here is let's break this down. Let's simplify this. This is going to be 3 times 9, which is 3 times 3. So this is radical 3 times 3 times 3. And we've got a pair of 3's here. So this is going to be 3 radical 3 plus 4 radical 3. Now once I've simplified, remember we mentioned we have to simplify these. Once I simplified, I have 3 radical 3's plus 4 radical 3's. That's going to be 7 radical 3's altogether. Now just to double check and make sure and convince you that we do actually have this right, I'm going to go ahead and pull up the calculator, and we're going to type in both of those expressions, and we're going to make sure that they actually look right, that they are exactly the same thing. I'm going to type in the original problem, radical 27 plus 4 radical 3. So that's going to be square root of 27. Again, make sure you hop out from underneath that radical. And then we've got plus 4 and then square root. We're going to put a 3 there and hop out from underneath. And we end up with 12.124. And then I'm going to type in 7 radical 3. And again, I'm going to hop out from underneath there and take a look at what we get. We get exactly the same thing. So this is the original expression, but this is the simplified expression. And I think you'll agree that this is a lot easier to write than the original problem. Okay, let's take a look at the next one. We've got 3 radical 8 minus radical 18. Again, please don't give up on them. Let's simplify these first before we make a decision. So this is 2 times 4, and that's 2 times 2. So we've got 3 square root 2 times 2 times 2, and then minus, let's see what we've got here. This would be 2 times 9, which is 3 times 3. So this would be the square root of, there wasn't anything out front, no coefficient out front, so 2 times 3 times 3. So let's take a look here. Pair of 2's, so this would be 3 times that 2 with a 2 stuck underneath. pair of 3's, so let's take the 3 on the outside with the 2 stuck underneath. So now what I've got is 6 radical 2 minus 3 radical 2. So now they do have the same root and the same radicand. These are both radical 2's. So again, I'm going to say it this way, and it would be a good idea if you thought about it this way. I have 6 radical 2's, subtract 3 radical 2's. Well, if I have 6 radical 2's and I take away 3 radical 2's, I would have positive 3 radical 2. And that is the answer. Okay, let's take a look at the last one, and then we'll do a couple from your assignment. Again, if you get a big number on some of these, please don't panic. This is an even number, so we know 2 goes into that. So 2 would go in there. If we divided 12 by 2, we'd get 6, and if we divide 8 by 2, we get 4, so that's 64. And then let's be smart about this. Remember, we're looking for pairs of factors. 64 is a perfect square. That's 8 and 8. So I'm going to write the negative 3 out front. I'm going to write a 2 and an 8 and an 8. We don't always have to go down to prime factors if we find that we've got a pair of factors there. And then notice we've done a radical 8 before. It's 3 2's. So I'm going to write down, we're just going to come right down here, and we're going to write down negative 5. And then this is going to be 2 times 2 times 2. And then let's simplify. Take out a pair of 8's. So this is negative 3 times 8 with the 2 stuck underneath. Pair of 2's here, so this is going to be the negative 5. One of those, that pair of 2's is represented by 1 on the outside. And again, we've got nothing to pair that up with. So we end up with negative 24 radical 2 minus, that would be 5 times 2, so that's 10 radical 2. So I have, and again, it really helps if you say it this way. I have negative 24 radical 2's minus another 10 radical 2's. Same sign, so we're going to find the sum. That's going to be 34. Keep that same sign, and that stays the same just like up here when we had the one x plus x is 2x, so that's going to be a radical 2. So if I have negative 24 radical 2 and I take away another 10 radical 2's, I end up with negative 34 radical 2. Okay, I'm going to slide down here and we're going to take a look at a couple of problems that are on your assignment. So we've got radical 45 plus radical 20. Again, we want to simplify these. We know they're both square roots, and maybe if we simplify, we would end up with the same radicand. So let's check and see. Again, this is going to be 5 times 9, and that's 3 times 3. So we end up with the square root of 5 times 3 times 3. This would be 5 times 4. And this would be 2 times 2. So this is going to be plus 5 times 2 times 2. So let's take a look at what we've got here. A pair of 3's with a 5 on the outside. On the inside. Pair of 2's, so that's going to be a 2 on the outside with a 5 stuck on the inside. So I have 3 radical 5's plus another 2 radical 5's. So altogether that is 5 radical 5. Definitely a lot simpler looking than that right there. And then let's take a look at number 16. So this is 2 times 9, which is 3 times 3. So we've got the negative 3 outside, that coefficient that was there to begin with. We've broken down the 18, so I've got a 2, a 3, and a 3. And again, they're fairly small numbers on the assignment, so a lot of these will come up several times. So this is going to be 2, and this would be 25. 2 times 25 is 50, and that's 5 times 5. And again, I'm showing all my work, every single bit of it. If you can skip down to here and just write down what the factors are, that would be awesome. So I've got a square root, I've got a 2, I've got a 5, and I've got a 5. So a pair of 3's. So I've got the 3 that was there to begin with, and then another 3 from that pair, 2 stuck underneath. And then I've got the 3 that was there to begin with, pair of 5, so I've got a 5 outside and then a 2 stuck underneath. So this is negative 9 radical 2. And let's see, this would be plus 15 radical 2. 3 times 5 is 15. So if I have negative 9 radical 2's and I add 15 radical 2's, again, they're different signs, so we're going to find the difference. The difference would be 6, and it's positive, so I get 6 radical 2. So I'm going to put a big circle around that, and we're all set to go. I do want to take a quick second to talk about some important ideas for the next test. That is coming up. We're nearing the end of the chapter, so I want to make sure we're clear on this. So these are some problems that are very similar, not exactly like, but very similar to some problems on your next test. So the first one says list the first 12 perfect squares. Now you don't have to write the problem, you can just write the answer. So if you've got those memorized, the first one of course would be 1, then 4, then 3 squared, so we're on the third one, 3 squared, so we'd have 9, and then 16. Fifth one would be 25, sixth one would be 36, 49, the eighth one would be 64, then 81, and then 100. The 11th one would be 121, and the 12th one would be 144. Let's just double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And you notice as I'm counting, each one of those is a perfect square of the number that I was on. And then we want to talk perfect cubes. Now this one says 6. It would be great if you could have 6 memorized, but definitely the first 5. 1, 2 squared is 8, 3 squared is 27, 4 squared is 64, 5 squared, remember that one, it comes up quite a bit because it's a fairly big number, but it's pretty easy to get the answer. 5 cubed, and then 6 cubed would be 216. Okay, so that one's a little bit above and beyond, but you should be in good shape there. And then again, let's talk about how we'd solve these. Now you'll notice that this is a mix of, we've got a quadratic here, a quadratic here, a quadratic here, but this one is a cubic. Okay, so that's a cubic equation, so we've got to remember how to do those. The approach for each one of these is the same, so I'm going to add 18 here, and this may look kind of familiar because we end up with 324. Again, large number, but we can deal with that, so I'm going to divide both sides by 4. We get b squared, and then this goes in there 8 times with, well, 80 times with 1 left over, I suppose, or 4 left over. This ends up being 81 if you need a calculator to do that. And remember, we undo the squaring by taking the square root of both sides. And when we put a square root, it's only when we do a square root, we also have to put a plus or minus on there. So we'll put that on there. And then the square root of 81 is, of course, 9. So I'm going to circle that. This one here, we're going to divide both sides by 4 like we did on that previous one. We get k squared equals, this would be 64 if you want to double check me on a calculator. We're going to take the square root of both sides, so this is going to be k equals. Again, we're putting a square root on here, so we have to put a plus or minus on there. And then the square root of 64, of course, is 8, so we're going to circle that. This one right here, gosh, nasty huge number, but we're going to go about it the same way. So we're going to subtract 1728 from both sides. Those are going to cancel, so I get n cubed over here is negative 1728, and then we're going to take the cube root on both sides. Now, when we start mixing these together, and it's been a while, remember, when we take the cube root, we've got to put that index there. That's going to be an n, and then remember, we don't have to put a plus or minus when we're solving a cubic equation. We're just going to put a negative here because it matches that sign there. And then, gosh, if we can guess what that is, great. I can't. So I'm going to be grabbing the calculator. We'll throw that in the calculator and we'll see what we end up with. So I'm going to clear this off, and this was the cube root. So remember, that's under math. It's the fourth one. Cube root of negative 1728. And we'll hope that this is a nice number. Again, we hop out from underneath there for good practice. Hit enter and we get negative 12. Wow, a little surprising. Okay. So that means if you cube negative 12, 12 times 12 times 12 would end up being 1728. And let's do this one right here. So we're going to add 91 to both sides. So this is 7x squared. Notice that it's a quadratic equation. We're going to add, let's take that 1281 plus 91. We end up with 1372. Pretty big number, but we're going to make it smaller right now because we got to get rid of that coefficient. So we get x squared, and then we take 1372 and we divide it by 7. We get 196. And then we're going to take the square root of both sides. Now when we take the square root, again, we've got to put the plus or minus on there, and I'm hoping that you recognize that one. Radical 196. 196 is a perfect square of 14. Again, we've got the plus or minus there. If you use your calculator, no problem. We're going to hit second and square root on that squaring button there. 196. Hop out from underneath. Tells us it's 14. Now notice your calculator will only give you the positive answer. We have to know that we're solving an equation and have to account for both of those. So please make sure you keep that in mind. All right. Good luck with the assignment and good luck with the upcoming test.